Imagination world. A place where reality starts to blur and the ordinary begins to fade away. A world where landscapes do not look natural, they look designed. Every scene feels unreal, yet everything exists within the laws of nature. This is not fiction. This is Earth at its most extreme and fascinating form. Across our planet, there are places so unusual that they challenge human perception. Locations where geology, climate, and time combine to create environments that seem almost alien. In this journey, you are not just exploring destinations, you are understanding how these extraordinary places exist. Let's begin with one of the most visually deceptive places on Earth, Chaka Lake in China. Located on the Qinghai Plateau at an elevation of nearly 10,000 feet, this vast salt lake is known for its incredible reflective surface. Over thousands of years, evaporation in a closed basin has allowed thick layers of salt to form, creating a solid white ground strong enough to support human weight. What makes this place truly unique is the thin layer of water that sometimes spreads across its surface. This creates a perfect mirror effect. The sky reflects completely, the horizon disappears, depth perception becomes distorted. People standing in the middle appear as if they are floating in space. Covering nearly 40 square miles, the lake creates a massive open visual field where simplicity becomes overwhelming. No trees, no structures, just white salt, shallow water, and an endless sky. Now shift your focus far into the Indian Ocean, near the island of Mauritius. Here you encounter one of the most fascinating natural illusions on Earth, the underwater waterfall. From an aerial view, it looks like the ocean itself is collapsing into a deep abyss. But in reality, there is no waterfall. This phenomenon is created by a steep underwater slope where fine sand and sediment continuously move downward. Mauritius sits on the edge of a continental shelf that suddenly drops into deep ocean waters. The angle of this slope can reach up to 40 degrees, allowing sediment to flow naturally due to gravity and ocean currents. Combined with the contrast between shallow turquoise water and deep blue ocean, this creates a powerful visual illusion of a cascading waterfall beneath the sea. From illusion, we move to a place where the Earth builds its own architecture, Pamukkale in Turkey. This location is famous for its white travertine terraces formed by mineral-rich hot springs. When underground water travels through deep rock layers, absorbing calcium carbonate along the way. When it reaches the surface, pressure changes cause minerals to deposit instantly. Over time, these deposits form solid white layers that grow into terraces resembling frozen waterfalls. The entire system stretches nearly 1,000 feet with an elevation difference of around 300 feet. Water continues to flow at a constant rate, meaning the formation is still active today. This is what makes Pamukkale extraordinary. You are not just observing nature, you are walking on a structure that is still evolving. Now the journey takes a dramatic turn, from open landscapes to the depths beneath the Earth's surface. Hidden in Vietnam lies one of the largest cave systems ever discovered, Doong Cave. This is not just a cave, it is a massive underground world. Stretching 5 Hawele miles in length and reaching heights of up to 650 feet, the cave is large enough to contain entire buildings. Inside, enormous stalagmites rise more than 200 feet tall, and underground rivers flow through complete darkness. But the most remarkable feature lies above. Over time, parts of the cave ceiling have collapsed, allowing sunlight to enter. Where light reaches, life begins. Entire forests grow inside the cave, completely isolated from the outside world. This rare combination of darkness, vegetation, and direct sunlight creates an environment unlike anywhere else on Earth. At this stage, one thing becomes clear. Earth is not just a planet, it is a system of extremes. From reflective salt deserts to underwater illusions, from living mineral terraces to hidden underground ecosystems, when every location reveals a different side of nature's power. And this is only the beginning, because what comes next will take you into landscapes filled with colors so intense, they feel completely unreal. From the hidden underground, our journey rises back to the surface, where the earth reveals colors and patterns so vivid they defy belief. Hormuz Island in Iran is a masterpiece of mineral artistry. Reds, oranges, purples, and yellows streak across hills and valleys. Layers of minerals pushed and exposed over millions of years create landscapes that look like a painter's wildest imagination. Walking through this barren land, you feel both the silence of history and the boldness of nature. Every ridge and cliff tells a story of geological persistence, a timeline older than human civilization. Far to the north, the Faroe Islands stand as a testament to nature's dramatic design. Steep basalt cliffs rise sharply from the Atlantic Ocean. Hidden valleys and jagged mountains create a patchwork of land and sea. The grass-covered slopes soften the harsh rock, while waterfalls tumble from impossible heights. Here, communities have adapted to survive in one of the most challenging terrains on Earth. Every village, every cliff, and every inlet is a story of human resilience, entwined with nature's grandeur. Shift to Lanzarote in the Canary Islands. The ground is blackened lava stretching like a frozen ocean. Volcanic cones rise like alien domes. Hardened lava flows ripple in layers, frozen mid-motion, echoing eruptions from centuries past. Low white houses contrast sharply against the dark landscape, while the endless blue sky frames the scene perfectly. Walking here, you feel both awe and humility, a reminder of the raw, untamed power of our planet. Nature and humanity coexist delicately, each aware of the other's presence. Further west, Madeira Island's Faroe forest invites you into a living cathedral. Ancient laurel trees twist and rise through centuries of wind and moisture. Moss carpets the ground like a soft green ocean, while mist drifts gently through the trunks. Sunlight pierces occasionally, illuminating the forest in ethereal beams. Walking here, the air is thick with life, history, and a quiet resilience. Trees over 500 years old whisper secrets of survival, adaptation, and the persistent power of nature. Next, we step into Hejra in northwest Saudi Arabia. Stone tombs carved into sandstone cliffs rise like monuments from another world. These facades, sculpted by a civilization long vanished, hint at a thriving culture that once dominated a crucial trade route. The desert stretches endlessly, amplifying their grandeur and mystery. Standing here, you can almost hear whispers of the past carried by the wind. Each grain of sand a storyteller, each shadow a keeper of secrets. Finally, we reach Teotihuacan in Mexico, a city of extraordinary design and monumental ambition. The Avenue of the Dead stretches straight and unwavering, flanked by pyramids and ceremonial structures. The Pyramid of the Sun towers 215 feet high, commanding respect and reverence. Walking through these avenues, you sense the lives of merchants, worshippers, and leaders who once animated this city. Precision, scale, and vision come together to remind us of human ingenuity and the enduring legacy of civilization. Now let's move deeper into the most extreme environments on Earth. Places where conditions are so intense that survival itself becomes a challenge. First, Danakil Depression in Ethiopia. When this is one of the hottest and most hostile places on the planet, average temperatures here often exceed 45 degrees Celsius. But heat is not the only extreme factor. The region sits at about 125 meters below sea level. This creates a unique geological pressure system. The surface is covered with salt flats, sulfur springs, and active hydrothermal fields. Bright yellow, green, and orange colors dominate the landscape. These colors are not artificial. They are the result of chemical reactions. Sulfur, iron oxide, and other minerals react with water and heat, producing these intense shades. Toxic gases like hydrogen sulfide are constantly released. This makes the air dangerous to breathe for long periods. Despite this, microbial life exists here. Scientists study this region to understand extremophiles, organisms that survive in extreme conditions. This research even helps in understanding the possibility of life on other planets. Now shift to Salar de Uyuni in Bolivia, the largest salt flat on Earth. It covers more than 10,000 square kilometers. During dry seasons, it looks like an endless white desert. The ground is covered with hexagonal salt patterns formed due to natural expansion and contraction cycles. But during the rainy season, a thin layer of water covers the surface. This transforms the entire region into the world's largest natural mirror. Reflection becomes nearly perfect. Sky and ground visually merge. Horizon disappears. This creates one of the most powerful optical illusions on Earth. Geologically, this area was once part of a massive prehistoric lake. Over thousands of years, water evaporated, leaving behind thick salt deposits. In some areas, where the salt layer is over 10 meters thick, it also contains a significant portion of the world's lithium reserves, making it economically important. Next, we move to Antarctica, the coldest continent on Earth. Temperatures can drop below -80 degrees Celsius. Winds can reach speeds of over 300 kilometers per hour. These katabatic winds are formed when cold air rapidly flows down from high elevations. Antarctica holds about 70% of the world's fresh water, locked in ice. Some ice sheets are over 4 kilometers thick. Despite these extreme conditions, life still exists. Penguins, seals, and specially adapted microorganisms survive here. One of the most interesting features is blood falls, a deep red liquid flowing from the ice. This is caused by iron-rich water oxidizing when it comes in contact with oxygen. It looks like blood, but it is a completely natural chemical reaction. Now move to the Amazon rainforest. Completely opposite conditions: high humidity, dense vegetation, continuous rainfall. It produces around 20% of the world's oxygen. The Amazon is home to over 3 million species of plants and animals. Many of them are still undiscovered. The ecosystem is extremely complex. Every layer, from forest floor to canopy, supports different life forms. But the real power of the Amazon lies in its climate control. It regulates global weather patterns. Deforestation here directly impacts rainfall cycles across continents. This makes it one of the most critical regions on Earth for environmental balance. At this point, one thing becomes clear. Earth is not balanced. It is extreme. Every region operates under completely different rules. Temperature, pressure, chemistry, and biology all change dramatically from one place to another. And as we move forward, the next locations will take us even further, into places where nature creates structures, events, and phenomena that seem almost impossible to exist. Now let's move toward places where Earth is not just shaped by nature, but actively being rebuilt in real time. These are not static landscapes. These are dynamic systems constantly changing under powerful natural forces. Start with Iceland. This country sits directly on the mid-Atlantic ridge. It is the boundary between the North American plate and the Eurasian plate. These two massive tectonic plates are slowly moving apart. The rate is about 2 centimeters per year. This movement may seem small, but over time, it creates massive geological changes. Because of this, Iceland is one of the most active geological regions on Earth. It has more than 130 volcanic systems. Many of them are still active today. Beneath the surface, magma is constantly rising. This creates intense geothermal activity across the region. You can see this in geysers, hot springs, and steaming ground vents. One of the most famous examples is Chaka geyser. It erupts every few minutes. Water shoots up between 20 to 30 meters into the air. This happens when underground water is heated by magma. Pressure builds up. Then it releases suddenly, creating an explosive burst. This geothermal energy is not just a natural feature. It is also used as a major energy source. Iceland produces nearly 90% of its heating from geothermal systems. This makes it one of the most energy-efficient countries in the world. Now, it moved to the Great Blue Hole in Belize. This is a massive underwater sinkhole. It is about 300 meters wide and more than 120 meters deep. From above, it appears as a perfect dark circle in the ocean. This structure formed thousands of years ago during the Ice Age. At that time, sea levels were much lower. This area was dry land. Over time, limestone caves developed underground. These caves slowly expanded and weakened. Eventually, the stuff collapsed. When sea levels rose again, the entire system flooded, creating a deep vertical cave underwater. Inside the blue hole, divers have discovered large stalactites. These structures only form in air-filled caves. This proves that the area was once above sea level. As you go deeper into the hole, oxygen levels drop. Marine life becomes limited. The environment becomes darker and more extreme. Next, move to Mount Roraima in South America. This is one of the oldest geological formations on Earth. It is estimated to be around 2 billion years old. It is a type of mountain known as a tepui. These are flat-top mountains with steep vertical cliffs. Mount Roraima rises sharply above the surrounding rainforest. Its top is completely isolated. Because of this, the ecosystem there is unique. Many plant species found on the summit do not exist anywhere else in the world. The conditions are harsh, soil is thin, rainfall is constant. Because of this, some plants have adapted in unusual ways. Many are carnivorous. They trap insects and absorb nutrients from them to survive. Clouds often cover the mountain. Visibility changes quickly. This isolation has turned Mount Roraima into a natural laboratory for scientists. It helps them study evolution and adaptation in extreme environments. Now shift to a much larger system, the Pacific Ring of Fire. This is a massive zone that surrounds the Pacific Ocean. It contains about 75% of the world's active volcanoes. This region is shaped by tectonic plate movement. Plates collide with each other. One plate is forced beneath another. This process is called subduction. As the plate moves deeper, it melts due to high temperature and pressure. This creates magma. The magma rises to the surface and forms volcanoes. Earthquakes are also extremely common here. Around 90% of the world's earthquakes occur in this region. This makes it one of the most active and dangerous geological zones on Earth. Now move to the Sahara Desert. It is the largest hot desert in the world. It covers about 9 million square kilometers. But this region was not always a desert. Thousands of years ago, the Sahara was green. It had rivers, lakes, and wildlife. This period is known as the African humid period. Changes in Earth's orbit affected rainfall patterns. Over time, rainfall decreased. Vegetation disappeared. the land slowly transformed into a desert. Even today, the Sahara is still changing. Sand dunes move continuously due to wind. Some dunes shift several meters every year. Entire landscapes are constantly reshaped. At this point, one thing becomes clear. Earth is not stable. It is always moving, always changing. Continents shift, climates evolve, ecosystems adapt or disappear. And the most important fact, these changes are still happening right now. Not in the past, not in theory, but in real time. And what comes next will take you even further, into extreme natural events where Earth pushes beyond its limits and creates phenomena that seem almost impossible. Now we move beyond landscapes and into natural events. Phenomena that are not fixed in place, events that appear, disappear, and sometimes happen without warning. These are the moments where Earth shows its most unpredictable side. Start with lightning. A single lightning bolt can reach temperatures of up to 30,000 degrees Celsius. That is 5 times hotter than the surface of the sun. It happens in a fraction of a second. But the energy released is powerful enough to split trees, melt sand into glass, and disrupt electrical systems. One of the most active lightning locations on Earth is Lake Maracaibo in Venezuela. This place experiences lightning storms for up to 260 nights per year. In some cases, there can be more than 25 lightning strikes per minute. This phenomenon is caused by a unique combination of warm air, moisture, and surrounding mountain ranges that trap storm systems in one area. Now move to tornadoes. These are violently rotating columns of air that extend from thunderstorms to the ground. Wind speeds inside a strong tornado can exceed 300 miles per hour. That is powerful enough to lift vehicles, destroy buildings, and completely reshape entire Magnetic tornadoes are most common in the United States, especially in an area known as Tornado Alley. This region creates the perfect conditions. Warm, moist air from the Gulf of Mexico meets cold, dry air from Canada. When these air masses collide, instability forms. Rotation begins. And under the right conditions, a tornado is created. Next, move to volcanic eruptions. These are some of the most powerful natural events on Earth. When pressure builds beneath the surface, magma is forced upward. When it reaches the surface, it erupts as lava, ash, and gas. One of the most powerful eruptions in recorded history was Mount Tambora in 1815. The explosion was so massive that it affected global climate. Ash spread into the atmosphere and blocked sunlight. This led to what is known as the year without a summer in 1816. Crops failed, temperatures dropped, and millions of people were affected worldwide. Now shift to earthquakes. How do these occur when stress builds along faults in the Earth's crust? When that stress is released, energy travels through the ground in the form of seismic waves. The strength of an earthquake is measured using the moment magnitude scale. Each increase of 1 unit represents about 32 times more energy release. This means a magnitude 7 earthquake is not just slightly stronger than a magnitude 6, it is dramatically more powerful. Some earthquakes can also trigger tsunamis. These are massive ocean waves caused by underwater seismic activity. In deep ocean water, these waves can travel at speeds of over 800 kilometers per hour. As they approach land, they slow down, but their height increases dramatically. This is what makes them so destructive when they reach coastal areas. Now move to wildfires. These are fast-spreading fires that consume forests, grasslands, and ecosystems. They are driven by heat, wind, and dry conditions. In recent years, wildfires have become more intense due to rising global temperatures. Some fires create their own weather systems. These are known as firestorms. Hot air rises rapidly. This pulls in more oxygen. Wind speeds increase, and the fire spreads even faster. In extreme cases, fire tornadoes can form within these systems. Next, consider glaciers and ice collapse. Large sections of ice can break away from glaciers and ice shelves. This process is called calving. When massive ice blocks fall into the ocean, They can generate powerful waves and contribute to rising sea levels. In Greenland and Antarctica, this process is accelerating. Warmer ocean temperatures weaken ice from below, and surface melting adds pressure from above. This combination speeds up ice loss and directly impacts global sea levels. Now look at sandstorms. In desert regions, strong winds can lift massive amounts of sand and dust into the air. These storms can travel hundreds of kilometers. Visibility drops to near zero. Air quality becomes dangerous. Some dust from the Sahara Desert even travels across the Atlantic Ocean. It reaches the Amazon rainforest and provides nutrients to the soil. This shows how connected Earth's systems really are. Even distant regions can affect each other in unexpected ways. At this point, the pattern becomes clear. Earth does not operate in isolation. Every system is connected. Atmosphere, oceans, land, and life all interact continuously. A change in one place can create effects across the entire planet. And the most powerful realization, these extreme events are not rare. They are part of Earth's natural system. They have always existed, but now many of them are becoming more intense and more frequent. As we move into the final phase, the next part will bring everything together. Not just places, not just events, but the complete system of Earth, how everything connects, and what it means for the future of our planet. Now step back and look at the bigger picture. Everything you have seen so far, extreme landscapes, powerful forces, and unpredictable events, is not random. It is part of a single, connected system. A system that has been evolving for billions of years. A system where every element influences another. The ground beneath your feet is not still. It is slowly moving. Continents are shifting. Mountains are rising. Oceans are expanding and contracting. These changes happen over long periods of time, but they never stop. The atmosphere above you is equally active. Air currents move heat across the planet. They control weather patterns. They shape storms, rainfall, and temperature. A small shift in atmospheric balance can change entire ecosystems. The oceans act as Earth's control system. They absorb heat. They regulate climate. They store energy and release it over time. Ocean currents connect distant regions. What happens in one part of the ocean can directly affect weather on the other side of the world. Now combine all of this with life. Forests, animals, and microscopic organisms all play a role. The Amazon produces oxygen and controls rainfall. Coral reefs support marine life and protect coastlines. Even bacteria help regulate chemical processes in soil and water. This is what makes Earth unique. It is not just a planet, it is a living system, complex, balanced, and constantly changing. But here is the critical point. This balance is not guaranteed. Inhuman activity is now influencing these natural systems at an accelerated rate. Deforestation is reducing natural carbon absorption. Industrial emissions are increasing atmospheric temperature. Ice is melting faster. Sea levels are rising. Weather patterns are becoming more extreme. These are not future possibilities. These are current realities. The same systems that create beauty and balance can also create instability when disrupted. And unlike natural changes, which happen over thousands of years, human impact is happening within decades. This creates pressure on ecosystems that are not designed to adapt so quickly. Some species survive, others disappear. Entire environments begin to shift. But understanding is the first step toward change. The more we learn about Earth, the more we realize how interconnected everything is. Every action has a reaction, every system has a limit, and every imbalance has a consequence. This journey was not just about discovering places, it was about understanding how this planet truly works. From reflective salt flats to underground ecosystems, from volcanic power to frozen continents, from violent storms to silent deserts. Every part of Earth tells a story of power, a story of balance, and a story that is still being written. The question is not whether Earth will continue to change. It will. The real question is, how will we adapt, and what role will we play in its future? If you found this journey insightful, make sure to subscribe and stay connected, because the more you understand this planet, the more you realize this is just the beginning.